equation of a line. We practiced graphing lines. We actually went through and we talked about slope. We did a lot last week. And so we're going to piggyback off of that this week with talking about some inequalities. And then I'm going to introduce the notion of what a function is for you. It's a big week. I tell students oftentimes that Algebra 1 can be broken down into 3 F's, right? You're about to get the first F, which is functions, okay? But before we do that, we're going to talk about inequalities on, you've done them on a number line. We're going to do them on the Cartesian plane. So I've started our recording and I've shared our screen with you. You guys see a little bit of a warm-up on the board. So I want you to go ahead and tackle these 3 warm-up questions for me, okay? I want you to work on these 3 warm-ups involving absolute value inequality, just a normal inequality, and a compound inequality. We'll give you about 2 or 3 minutes to work on that, and then we will we'll see how you did.
Do we need to graph the bottom two?
If you want to, you can graph the bottom 2 to help you figure out the solution, but no, you do not have to. When it says solve, you can solve it just giving the interval notation or doing our regular old, inequality notation. This rusty old bike is driving me nuts. I'm going to throw it in the dumpster today. That kid has had plenty of time to get rid of it. Take it back home. Let's see here. 1, 2, 3, 4, 5, 6, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I gotta figure out my feng shui in here. I do not like all of this. The table's up there. Little desk back there. I'm OCD about that kind of thing. It's gonna drive me nuts until I get it figured out. All right, y'all ready? Grove, what'd you do on the first one? Absolute value of x is greater than 2. Graph that on a number line. How do I do that?
On the first one, I subtracted 2 by 1.
Why would you subtract 2 by 1?
These are 1s.
So that's absolute value. You know what absolute value is? We spent a whole section talking about it. Nate, what did you do on number 1? X is greater than 2, the end, or x is greater than 2, ... How dare you forget something that I taught you? I've worked blood, sweat, and tears to teach you guys that it is absolute value is greater than 2. What does that mean, Will Edwards? Greater than 2? I emphasized the word or when I said greater than 2. Yeah, x is greater than 2 or x is less than negative 2. Okay, so y'all have already forgotten something that we talked about. When I graph that on a number line, I got an open mark. I'm going to shade to the left of negative 2. I got an open mark, and I'm going to shade to the right of positive 2. Okay, so warm-ups are meant to accomplish 2 things. They're meant to keep us fresh in our mind, so those things that we've already learned, right? And they're also meant to prepare us for some new things that we're going to learn today. And so if you have already forgotten about your absolute value inequality, go back to probably about section 2.5, 2.6, somewhere in there, maybe 2.7, and look back through your notes. But when you've got absolute value of x, that means that the distance that x is away from 0 on a number line. And when it says it's greater than 2, what that means is that x is in some number that's to the right of 2 and to the left, or excuse me, to the left of -2. Okay? So like the number 5 would work, because 5 is farther away from 0 than 2 is. The number -7 would work for the same reason, right? -7 is farther away from 2, or from 0 than 2 is. Okay? Now, going back to Grove, a little chance at redemption here. What do I do to solve number 2? This. All right.
Get -4x is greater than or equal to,
Mm-hmm.
and then divide by -4. Get x is greater than or
George, you should get what?
x is
What? 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 You said 20.
Oh, I meant 5.
What?
5. -5.
-5. Okay, so we've established that it's -5. Oh boy, y'all's brains are still on the weekend here. Tiago, what do you think?
Since you're dividing by a negative, you have to switch around the greater than or equal to sign.
Yeah, we got to reverse the direction of our inequality. Whenever we multiply or divide by negative. And so if we wanted to graph that out, I know it didn't ask you to, but if we wanted to graph that out, there is -5. There's a closed mark, and we're going to shade to the left. Or if we wanted interval notation from -infinity up to -5, and then brackets. Okay. Last but not least, Joey, what kind of statement is number 3? Joey, this will be where you unmute your microphone. Striking out today, fellas. I feel like such a failure. Charlie Griffith, what do I do on number 3? What kind of statement is that?
An and statement.
It's an and statement. If we wanted to visually split this up, we would say, okay, there's one statement, and there's the other statement. Did you guys do that? All right. All right, Alex, what do I do to that first statement? So -4, and then 2x, and 2x, +4, okay. Next. Alex? There we go. Divide by 2. Here, I'll drag that up so you guys can see it a little bit better. X is less than 2. And therefore, we could put them together. And x is between -2 and +2. Again, if we wanted to graph that out on a number line, open mark. Whoops. Open mark on both of those. And we're going to shade between -2, comma 2 if we wanted our interval notation there. All right. So shame, shame, shame. Seems like we're forgetting a little bit about inequalities, and that's okay, because in this section, we're going to talk a bunch about inequalities, just not on the number line. We're going to talk about inequalities in 2 variables, and this is going to be, as I mentioned, a segue off of last week's work that we did. Remember last week when we talked about graphing lines, we talked about slope as that characteristic of which way the line is going. We're going to talk more about slope this week, y-intercepts. All right, we're going to talk about that. But we're also going to discuss, when you're graphing inequalities, that notion of what kind of mark should I use and where should I shade. And in fact, those 2 questions are going to be answered on this screen right now, okay? So again, the 2 questions are, what kind of mark, and I put mark in parentheses, should I use, and where should I shade? If we can figure out the answer to those two questions, then this lesson will be no different than it was last week. Okay, look at the first couple drawings up there, and you'll notice that they both involve what kind of line? A dotted line. Am I speaking a foreign language up here? Are you guys okay? What kind of line is this? And you're, oops. And you're like, I don't know what he wants me to say. What do I say? What do I say? Yeah, dotted line. That's a dotted line. The reason that we're using dotted lines here is because those inequalities are strictly less than and strictly greater than. Okay? Can you put those 4 drawings in your notes, by the way? So in your notes, you're copying these drawings down to help you figure out the answer to those 2 questions. What kind of mark should I use? Well, fellas, if you've got an inequality that is strictly less than or strictly greater than, and you're graphing it out on the Cartesian plane, which means we have an x and a y, then you're going to have a dotted line. But if you've got an inequality that is inclusive, in other words, less than or equal to, greater than or equal to, that's going to be where we where we draw the line in a solid fashion. Okay, so a solid line means that I'm including the points on that line as my solution set. A dotted line means I'm excluding the points on my line as far as the solution set goes. And then, when we talk about shading, the values that are less than or equal to are below the line. Okay, less than equal to, those are where we shade below, quote, below the line. Can you kind of tell that's where it is? It's underneath the line. And then the values that are greater than or equal to, right? Where do we shade on those? Shade above the line. Okay, so those values that are up above the line, that's where we shade on those. Okay. So this is a good summary for us of what to do when we have a basic linear inequality of 2 variables. Remember, this is different than just like what we saw in the warm-ups, like x is less than 5. If you got x is less than 5, you can just graph that on a number line. But if you've got y is less than 1/2 x plus 3, that's a linear inequality of 2 variables, so we have to graph it on the Cartesian plane, as opposed to the number line. Okay. So here's our first example. And this one's going to actually be a simple enough example to where we don't have to bust our brain too much on it. We're given a linear inequality of 2 variables, so we got y is greater than x plus 4. And we want to just simply determine which of the following points are solutions to that inequality. Okay? Now, how can I tell, Luke, if a ordered pair is a solution to an equation, or in this case, an inequality?
By plugging it in.
Yeah, if I plug and chug and get a what? Get a true statement. So let's try it out. We got y is greater than x plus 4. And once you get the hang of this, you will not have to write it down. But to start with, what we're doing is we're plugging in coordinates, and we want to see, is that true? Is 0 greater than 0 plus 4? No, so we would say, this 0, 0 is not a solution. Okay, now graphically, what does that mean? That means that it's not on the region that I have graphed, that I have shaded, or that I've covered with my line. Okay, let's try the second one here. What about 6? Is that greater than 1 plus 4? What would we say? Yeah, of course. So that means that 1, 6 is included in my solution set. Okay, winner, winner, chicken dinner. So that one is going to be either on my line if it's a solid line, or in the shaded region if that's the case. And we can quickly go through and we can determine, okay, just what is x plus 4, and is that going to fit the bill with y? Okay, so in other words, is 6 greater than 2 plus 4? No. Is negative 15 greater than negative 5 plus 4? We had some confusion on that one. Let's make sure we understand each other. What we're testing out is to see is negative 15 greater than negative 5 plus 4. So that's going to be negative 1. That's going to be negative 15. Is that the case? No, it is not. That one fails. Okay. And then last but not least is 12 greater than negative 8 plus 4. Bet your biscuits it is. Yes, indeed. So when we look at this graph, y is greater than x plus 4, let's just take time out for a sec and see if we can plot that out. Okay. Jake, where do I start on a graph like that, where I've got y, and I think I might have said equals, but we're treating it like it's equals. Y equals x plus 4. Where do I start on a graph like that?
The y-intercept.
Good. And what is the y-intercept?
0, 4.
All right. So we're going to put a dot right there at 0, 4. Because what form, Jack, is that inequality in regarding linear forms? What form is that in? Is that standard form? Is that point slope form? Is that slope intercept form? Or do we know? No clue yet?
Wait, it's standard.
Try again. Those are our 4 formulas that we talked about last week, the 3 of which, green and red and blue, are our 3 forms of linear equality, or linear equation. So what do you think? Shall I go back to the example? There's the example. Okay. So which one of those 3?
I think it's standard.
Okay, so you got y by itself on the left.
Oh, slope intercept.
Slope intercept. Good. It's this one right here. So the reason that Oxley said, hey, you got to start at y equals 4, because that's y equals mx plus b, and b is our y-intercept. So what does that mean, Reed, that my slope is on this one? Have you spotted what the slope is? It's the number in front of x. Yeah, so our slope is 1 here. Now, fellas, I don't know about you, but when I've talked for a week about the forms of a linear equation or inequality in this case, and we've got y by itself, we identify y equals mx plus b. I kind of like that. Y equals form or slope intercept form is nice because it tells me which way to start and which way to go. Okay, so if I've got a y-intercept of 4 and I got a slope of 1, remember slope is rise over run. And so that means I go up 1 into the right 1 or down 1 into the left 1. Now, I don't have to make all these points, but I guess I will. Just to kind of show you what I'm talking about there regarding slope, right? I got all these little points. What do I do when I got all those points? I connect the dots to graph the line out. But my point here is, no pun intended, that this is a dotted line. This needs to be a dotted line because of the strictly greater than, the exclusive inequality that we're dealing with there. So I'm going to put my dotted line right there. Okay. And you tell me, Lewis, should I shade above that line or below that line based on the previous slide? The fact is y is greater than x plus 4.
Above the line.
Yeah, absolutely. So what we're going to do is we're going to shade this region. We're going to say that our solution set contains all of the points that are above that line. Not on the line because it's dotted, but above that line. Okay? Now, look at the answers that we had just run through in this example. Was 0, 0? Did 0, 0 give me a true statement? No. Guess what? We didn't shade over that. Did 1, 6 give me a true statement? Yes, we shaded over that region. 2 comma 6, did it give me a true statement? No, it was on the line. You might have noticed that, right? You might have noticed that if I plugged in 6 for y and asked, is that greater than 2 plus 4, plugging in 2 for x, we had 6 is greater than 6. That's close. What would have made that true? Good, George. Greater than or equal to. In that case, what kind of line would we have drawn? Well, all lines are straight. A solid line. We would have drawn a solid line, and therefore we would have included that point in our solution set. In your notes, write down that a solid line means we are including all of the points on the line as well as our shaded region. A solid line means that we're including all of the points on the line as well as the shaded region in our solution set. Sadly, on this one, we did not include that third point right there because it was strictly greater than. Okay. Same thing with -5, -15. You know, it doesn't take a brain surgeon to figure out that way down here, you know, -5, -15, we weren't getting a true statement. But -8, 12, way on over here somewhere, and that's in the shaded region. So the two numbers that or the two ordered pairs rather, that we said we liked, those were in our shaded region, right? There was E, oops. There was E, there was B, and we said we liked that. C we did not like, A we did not like, D we did not like, okay? Any questions on example 1 and how that worked out? Let's look at another one then. This one, I'm going to give you the graph, and I'm going to ask you for the inequality. So here's a couple things that I want you guys to do. Number 1, I want you to figure out, well, okay, well, what would if this was just a line, not an inequality, but if this was just a line, a linear equation, what would it be? Okay, and again, to go back to Jake's point earlier, we want to start at the y-intercept. Can you tell what that y-intercept is? -1, good. So, Jack, when we put it in y equals form, right? Y equals mx plus b. Let's replace some things. Jack, what do you want to replace to put in -1?
B.
Very good. That b value right there, that's our y-intercept. That's what we're going to have be -1. Okay. Has anybody identified our slope yet? Has anybody done the rise over run? You guys kind of eyeballed this and seen what your slope is? What do you think there, Went? 2/1. Good. We go up to, whoops. We go up to and to the right 1. Up to and to the right 1. Up to and to the right 1. You know, that's our rise over run. So identifying the slope tells me what m is. 2/1, or we'll just say 2. Of course, I'm going to have y in there. But I'm going to replace that equal sign next. Because it's not an equation. It wasn't just a line that was graphed out. It is a dotted line in a shaded region. So here's a 4-point multiple, or 4 options multiple choice question. Is it less than? Is it greater than? Is it less than or equal to? Is it greater than or equal to? What do you think? It's greater than. Because of the dotted line, I know I'm going to use the exclusive inequality. It's going to be strictly, and then greater than because we shaded above, so to speak, the line. So there we go. So we swapped out all 3 of those from last week from our y equals mx plus b. Now we're good to go. So, and I know this, by the way, I know that looks like a times. Sorry, I didn't mean to put parentheses there. Okay. So what we've done is we have got our inequality right here that matches the given, graph. Okay. One of the nice things about a graphing calculator is that it can help you with problems like this. I think last week we might have talked about Desmos. If you were to go to Desmos and you were to like check your answer, all you'd have to do is just graph out y is greater than 2x minus 1 and see if it looked like this guy. And if like, let's say I made a bonehead mistake. Let's say on Desmos, I came over here and I did like y is less than 2x minus 1, right? It would be this graph right here. And I would quickly realize, oh, I need to reverse the direction of my inequality, okay? Or let's say instead of a dotted line, let's say I did that and I got a solid line. So you need to quickly sort of troubleshoot and find the mistake that you made. And a graphing calculator can be very helpful for that when you guys are kind of testing out those types of answers. All right. I'll tell you what we'll do. We'll leave off with this one. We'll start with example 3 tomorrow. And I believe, did I give you guys homework over the weekend, Delta Math? All right. If you have any questions about that assignment, I'm assuming you're going to have some based on our performance in class today. Then bring those up tomorrow because I'm going to give you another assignment tomorrow with inequalities on Delta Math. And I want to make sure we get all our questions taken care of beforehand. Okay. So, hey, good job today, fellas. I appreciate y'all's effort. Be safe and live Jesus in our hearts. All right. Guys at home, I will see y'all tomorrow. Hey, good news. My clock